Today we're going to combine our last two lessons, the one on measures of dispersion and central tendency, along with creating frequency tables and histograms. So we're going to practice all of those things. Let's review. Today we have a new data set, the scores for the ladies' short program in the 2018 Olympics, rounded to the nearest whole number. So if you watch ice skating, then you know that the skating scores are given out to like the nearest hundredth or so. But that would get really tedious for our purposes here. So I found the actual data for the ladies short program from 2018 Olympics, and then I just rounded all the numbers off to the nearest whole number to make them a little bit easier to work with. So we're asked to calculate a few things. The first is the mean. Remember, when we calculate the mean, we're taking the sum of all the numbers, so adding up all the numbers in the data set, and then we're dividing by how many numbers there are in that data set. Well, if you count the numbers in our data set, you'll see that there were 30 entrants in the ladies short program. So there's 30 data values. And then if you take your calculator and you add up the 83, the 82, the 79, the 76, et cetera, all the way to the 44, you will find that the sum of all those numbers is 1,828. So then you take your calculator and you divide the 1,828 by 30, and you'll get that the approximate average or mean score was 60.9. So that's the mean score for the ladies in the short program for ice skating in the 2018 Olympics. Now we're going to calculate the median. Now, conveniently, because the competitors were listed by rank, so obviously the highest score is the best score. So the highest score came first, the lowest score came last. So this is in reverse order from the way we usually look at it. We usually go from least to greatest, but frankly, it doesn't really matter for the median. It just matters that they're in order. So since this is in descending order, we don't have to rewrite all this data. We can just start crossing up a high and a low each time, making sure we pair them off. If we cross off a high, we also cross off a low all the way through. Whoops, I missed one. Until we're left with just one data value in the middle, except that we know that there are 30 data values, which is an even number. So we're actually going to be left with two data values in the middle. So remember, for the median, we are looking for the number in the middle, the literal middle, when the numbers are listed from least to greatest. Well, we don't have a literal middle. We have two numbers at the middle, 59 and 57. So we take the mean of those two numbers, so we add them up and we divide by 2. Well, that's going to give us 116 divided by 2, or 58. So the median score for all the competitors was a 58. Finally, we're looking for the mode as our third measure of central tendency. Sometimes there's no mode at all in a data set. Maybe none of the numbers repeats. Sometimes a data set has more than one mode. And this is one of those cases. In fact, we would call this data set bimodal, because there are two numbers that repeat the same number of times. Now, if you look through your data, you'll see that there are 3 55s. But you'll also see that there are 3 51s. Because they repeat the same number of times, they each occur, quote unquote, the most. So this data set is bimodal. There are two modes. So the modes are 55 and 51. There aren't any values that occur more than 3 times. And even if something else is repeated, like 64, it doesn't count as one of the modes because it only occurs twice. So it doesn't occur the most number of times. So there are two modes, 55 and 51, for this data set. Now that we've looked at the measures of central tendency, what's going on at the middle of the data set, we're also being asked to look for the range, the measure of dispersion. Remember, the range is found as the biggest number minus the smallest number. In this case, the top score was 83, and the lowest score was 44. When we subtract, we get that the range of data was 39 points. Next, we're going to review back to the first day of this unit, frequency tables and histograms. Now, on our first lesson, we were told what our intervals should be. And today, we have our first practice at determining what the intervals should be. So let's look at our data. Typically, we want to have around 5 intervals, maybe 4, maybe 6 or 7, but usually around 5. So let's look at the values. Our range was 39, so that's a spread of almost 40 values. If I want to have each of those be equal in size, and I want to have around 5 values per data set, well, 40 divided by 5 is 8. So the width of my intervals needs to be around 8. That gives me kind of a guess for how to start. So then I look at this, and I'd like easy intervals to work with. So if I started at 44 and went up by 8, I'm going to be dealing with a lot of awkward numbers all the time. So if I go a little lower, maybe I go down to 41. If I round 8 up to like 10, that would take me to 50. Let's see if working this way gives me 5 or so reasonable intervals. If I go 41 to 50, I can go 51 to 60, 61 to 70, 71 to 80, and I know that highest value is 83, so 81 to 90. Notice that does in fact give me 5 intervals. So that seems like a good way to set up our frequency table. It's not the only choice we could have made, but it's a pretty easy one to work with. So since our data is in order, it should be pretty easy to figure out how many values are within each interval. So from 41 to 50, well, 1, 2, 3, well, there's only 3 data values in that. From 51 to 60, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 values. That was a very popular scoring range. Then 61 to 70, 1, 2, 3, 4, 5, 6, 7. 71 to 80, 1, 2, 3, 4. And 81 to 90 just has 2 values. So we've set up our frequency table to represent this data. Now remember when we set up a histogram, the intervals are going to be the exact same intervals that we used in our frequency table. So we're going to have 41 to 50, 51 to 60, 61 to 70, 71 to 80, and 81 to 90. So this table is actually a little bit wider than what we really need. These are our intervals across the bottom. Going up the side, we'll have frequency. And the question becomes, can we count by ones or do we need to go up by maybe more than that, have a little bit of a different scale? So the greatest frequency we have is 14, and we can tell at a quick glance, there are not 14 spaces going up the frequency. So let's go by 2. So we'll have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so we've got our frequencies labeled going up the side. And now it's just a matter of translating the table into the graphical representation of the histogram. So our first height has to be 3. Now remember, we went by 2s, so that's going to put us right in the middle. Our second one goes all the way up to 14. That's going to be our tallest bar by quite a bit. Then to 7, so that's going to put us in the middle again. Then 4. And finally 2. We now have a completed histogram that represents the frequency table that we created up above. That's the whole classwork assignment for today. Today was an easy one. You didn't have to do anything on your own. Just take a picture of your completed note sheets and upload it in the Google Classroom so that I can give you credit for your work today.